4.3 covers rate of change. Rate of change basically describes how one quantity changes in relationship to another. We have discussed rates here the last couple days and talked about rates and proportional and everything of that nature, but rate of change is going to talk about it can be an increase or it can be a decrease, but it is a rate of change. So we look at our first example here. This key concept here is basically showing you that there's a positive rate of change, meaning that it's an increase, and look how the line slants upwards. We have a negative, a decrease, and the line slants downwards. So those are our rates of change. We could have an increase or a decrease. How to find out rate of change? Well, first off, we're going to deal with the positive rate of change. What we need to look at, it says dogs. The table below shows the weight of a dog in pounds between 4 and 12 months old. Use the information in the table to find the rate of change in the dog's weight between 8 and 12 months of age. So it's talking about the dog's weight and the month of age. So we need weight over age. Now, in order to find this rate of change, we need to use the two values that they're talking about, and they're talking about between 8 and 12 months. So here's what we're looking at. From 8 to 12 months would be dealing with those two pieces of information. It is an increase. The reason why I know it's an increase because it goes from 28 pounds to 43 pounds. So I know it's an increase. Now we need to figure out that increase. Well, the weight would be 43, take away 28 to find that difference. The age would be 12 minus 8 to find that difference. Now if you look at it, these variables here, 43 and 12, correspond with one another in the table. That's how I'm pulling that out. 28 would correspond with 8 in that table. That's how we're taking that out. So we go ahead and figure out our difference here. The rate that we have would be 43 take away 28, giving us 15, and 12 minus 8 giving us 4. So the rate is 15 over 4. And basically what that is saying is this top 15, remember, is talking about weight. So 15 pounds, and age is 4 months. So the rate of change is 15 pounds per 4 months. Now you could use this to figure out the unit rate, which was basically dividing 15 divided by 4, which is 3.75 you'd wind up with, and this would be pounds per month. So that the increase from age 8 to 12 basically increases 3.75 pounds per month. In example 2, we're using heights. The table below shows Julia's height in inches between the age of 6 to 11. Find the rate of change in her height that we have here. So the height between ages 6 and 9. So we have height listed first over age second. And the values that we are using is ages from 6 to 9. So 6 to 9. These are the values that we are using. And again, looking at our table here, we can see that it's an increase. It goes from 52 to 58. So we need to find that rate of increase. So again, we'll take 58, our height, take away 52. These are the heights that we're using. Now in relationship, 58 corresponds with 9 in our table, so 9 will go below that, the age of 9. And the below 52, look back to our table, we have 6. So 58 take away 52, we get 6. 9 take away 6, we get 3. So basically what our rate is talking about here is we have 6 inches in 3 years. Okay, the height was in inches, so every 6 we grow 6 inches in 3 years. Now we'd want to reduce this here, get 6 over 3 would reduce to basically 2 inches per year. Okay, inches, year, so 2 inches per year would be our positive rate of change. Example 3, the graph shows the number of students in the 8th grade between 2000 and 2004. Find the rate of change between 2002 and 2004. Looking at our table here, the rate of change from 2002 to 2004, 2002 to 2004. If you look at our values here from 2002 and 2004, we know that that is a decrease because it is a downward slant. So we should wind up with a negative rate. Now, this is a good thing to write down here. You'll use this a lot. To figure out rate from a table or a graph, this is how we set it up. It is the change in y over the change in x. So this would deal with our vertical axis, and this would deal with the horizontal axis. Okay, so if we look at this here, this is our horizontal axis, that is x. This is our vertical axis here, this is y. So the two values that we are using are our change in y is basically talking about the number of students. That is my x-axis. My y-axis, right here, the x value is the horizontal axis. That is talking about year. Now, if we look back in our table, or actually back in this problem here, it says that we need to use values from 2002 to 2004. 2002, 2004 are years. So it's the change from year to year. So we have 2004, take away 2002. Put your finger on the 2004, go up until it hits that line. In 2004, we had 459 students according to our graph. So I'll put 459 down. Figure out in 2002. Well, 2002, we go up until we hit that line, and we have 485 students. So minus 485 to figure that change. When you do your division here, we wind up with negative 26 on the top over 2. Basically what that's saying is we lost 26 students, because it's negative, in 2 years. Now we need to go ahead and simplify that. This right here, when simplified, we get negative 13, basically students per year. Again, the 26 on the top is talking students, here is talking years, so students per year. Example 4, schools, a graph showing that the number of students in the 6th grade between 1999 and 2005. Find the rates of change from 2003 to 2005. So we look at 2003 down here, and we look at 2005 down here. Here's our points that we'll need to use. Again, this is a decrease. So if it's a decrease in rate, we should have a negative rate. To figure out this rate, again, we do our change in y over change in x. The y-axis, our vertical axis right here, is talking about the number of students. Our x-axis, our horizontal axis, is talking years again. So I'm going to go ahead and write that information out, number of students over years. The two values that we need to use again are 2005 to 2003. So here we go, 2005, take away 2003. Well, we know that that's going to be a difference of 2 years. You look at your 2005 data, and we come up and we have 301 students in 2005. Notice how they're above and below one another because they correlate with one another. They belong with one another. In 2005, we have 349. Now we're going to take it away because we want to find that change. And when we take 305 minus 349, we wind up with negative 48 on the top. So basically what that's telling us is we lost 48 students in 2 years. To break this down, to simplify, it's basically we lost 24 students per year again. Our last problem here, temperature. The graph shows the temperature measured on each hour from 10 a.m. to 3 p.m. during which 1 hour period was the rate of change in temperature the greatest. So we have to go ahead and figure out all these rates of change from each given hour. So we have from 10 a.m. to 11 a.m. We need to figure that out. From 11 a.m. to 12 a.m. from 12 a.m. to 1 p.m. from 1 p.m. to 2 p.m. and last would be 2 p.m. to 3 p.m. Need to find out all the rates of change. Again, it gives us our rate of change, which is a change in x over the change in y. X is talking about our denominator there, which is the change in time, our horizontal axis. Our numerator, the top part of the fraction, is our change in y, which is the change in temperature. So we need to go ahead and use these values here. So I'll help you out with this first one here. And we have the change in time. Well, we went from 11 to 10. At 11 o'clock, we go up and we hit the line up here. Well, the temperature is 55 degrees. At 10 a.m., our temperature is 54 degrees. So I do my subtraction here. I have 1 over 1, which equals 1. And that is 1 degree there. So basically it changed 1 degree in 1 hour. Think of it like that. 11 to 12. So again, we go from 12 to 11. We have at 12 o'clock, we go up and we hit our line up here. Looks like we have 59 degrees. At 11 o'clock, it is 55 degrees. We have a difference of 4 and 1. So 4 degree change there in that hour. Now, when we do this down here, this is a difference from 1 hour. You can't really say 1 minus 12. You'd have to actually use military time here, or know that it's a difference of 1 hour from 12 o'clock to 1 o'clock. Otherwise, you can use military time here. 1 p.m. is 13. 2 p.m. down here would be 14 p.m. and 3 p.m. would be 15 hours. So go ahead. I'll help you out with this next one from 1 o'clock to 12 o'clock. So we'd have 1,300 hours minus 1,200 hours. At 1,300 hours, or 1 p.m., our temperature was 60. At 12 o'clock, we look back at 12 o'clock and it was 59. So take away 59. And it's an increase, so it should be positive. And we have 1 over 1, which equals 1 degree. Go ahead and figure out your temperatures for 14 from 1 to 2 and 2 to 3, and then we'll figure out which one had the biggest rate of change. So pause the video and work through those last two. After working through the last two there, from 1 p.m. to 2 p.m. here, basically from 1,300 hours to 1,400 hours, we'd set up our equation here, and then we'd wind up with 0 over 1. Figuring out that there is no change. And looking at your graph, you can easily determine that too. So if you look at our graph, we have 1 p.m. to 2 p.m. So from here to here, it didn't increase, it didn't decrease. Therefore, it had a 0 degree change. Last from 2 p.m. to 3 p.m., so from 1,400 hours to 1,500 hours, we had a degree change of 2. So 2 degrees. So the question, now that we've wrote everything out and we figured it out, we had to figure out during which 1 hour time period did it have the greatest change. Well, that would be from 11 to 12. We had a 4 degree change. It increased 4 degrees. This will conclude our lesson on 4.3 rate of change.